So thank you all for heading this direction. This is one of my personal favorite quotes. It is. I spent most of my career at Stanford in the School of Engineering. As a humanist, it was a little bit of disconcerting, but I love this sort of engineering focused quote, which is the future is already here. It's just unevenly distributed, and I think that the notion here is, with regard to constantly being educated, and thank you for joining here, is we hope to share some experiences today that will at least elevate your perspective, especially in the VR, AR space.
So I was pleasantly surprised how language teachers are now using virtual reality to get people to learn. If you just sit and lecture to them, it's one thing. But now when you get people to move on a treasure hunt, when you ask questions, the language is better retained.
DP, this is Karen. I'll just comment too, I love the detail of the rain, the detail of the marbling of the column and the way the building is set up. It makes it feel so much more real, the subtleties. Well done.
Thank you, Karen. And we are at the, think about this as a minimum viable product, point one. A lot more is coming, and this is Lisa guiding with Mike, and Mike's ingenuity there coming together. So now pretty much anything we can envision, any of us can envision, can be architecturally designed and constructed, and we can use it just like we use our physical assets. So that's where we are at an absolute leading edge of how to do that and how to do it faster.
And adapting a couple of things, I would say, just to amplify, DP, your minimum viable product. This really has come together over the last sort of week to 14 days. And the exciting thing is that, we get a chance to build an environment. It is not as detailed as, say, the latest Star Wars movie or name your favorite other feature film, and it provides some perspective and enough emotion that you can really get a sense and a feel for the space. You can model literally anything that you set your mind to, and we're delighted to have Mike on our team to support this. This was literally an idea he had last weekend, which was sort of a work that he had done previously and it pulled together. So very, very excited about that.
This is an example of a field experience as we're walking through.
Temple 328 Heavy departure.
Temple 328 Heavy, radar contact, climb and maintain flight level 230, moderate turbulence from 14 to 220.
Okay, understand. Thanks for the PI rep. Cleared to climb flight level 230, Temple 328 Heavy. Temple 328 Heavy, experience an engine failure. Need to get to access to the nearest airport.
Call command, Mayday, Mayday, Mayday.
Mayday, Mayday, Temple 328 Heavy, Mayday, Mayday, aircraft.
Temple 328 Heavy, say again, please. Read all that again.
Yes, Temple 328 Heavy, Mayday, aircraft experience an engine failure and need nearest airport with equipment ready.
Okay, Temple 328 Heavy, maintain 9,000 at pilot's discretion.
Okay, descending to 9,000, maintain Temple 328 Heavy.
Okay, Temple 328 Heavy, cleared to land in Springfield.
Okay, Temple 328 Heavy, not immediate. We need to run some checklists.
Okay, Temple 328 Heavy, Roger, just let me know what you need to do to hold for left turns.
Very good, Temple 328 Heavy.
Temple 328 Heavy, when possible, fuel and souls on board and contents.
Go, go, go.
We'd like to land as soon as possible in Springfield and give you souls in just a minute, Heavy.
How did we miss the malfunction?
Temple 328 Heavy, cleared to land at Springfield, plan on a full stop and equipment will come to beat you and we will need you from there.
Released.
Temple 328 Heavy, descending rapidly, not looking good here.
That control's giving way. Push
Temple
right,
328
push
Heavy,
right,
come
right
again.
now. Look, there's the water.
Temple
That's our
328
chance.
Heavy,
Right.
Gotta pull up, gotta clear the mountain.
Temple 328 Heavy, come in please.
Here's the picture of my kids. Text your family. Text your family. Ray, crew, it has been an honor. The deck. Pull up. Right. We may clear it. smoke in the cockpit. Left wing. It's gone.
If I could get everybody to come back down to the to the black box area, would appreciate it. I just want to tell a quick story. So a colleague of mine talked about a program that she was running in air aviation safety, and one of the challenges was how could you reproduce an environment that would allow the level of detail that you might see when you actually review in a hangar airline crash and the broken wings and so on and so forth. And in fact, while you can't recreate the physical detail right now, you could imagine that this entire scene, including the setting where a crash might have occurred, you could replicate here. The other thing is, if you haven't had a chance to walk through the black boxes, you can actually see reasonable level of detail through that. Just poke your head right through. You can walk through and see the components inside the black box, as big or as small as you wish, just to get a real sense of what's happening there. And I think the other thing is that, of course, we can walk literally through the fire, see the direction of the fire. You can almost feel the heat coming from the fire. You can hear the sort of tapered sound as you walk through that environment. And the idea here is that you have a chance to really experience something that is quite unique with a level of focus that I think is impactful. Just as a bit of background, so we were doing a little bit of research for this field crash site test, and we worked on, we looked at the data from a recent crash of Asiana flight.
Switched the autopilot to flight level change mode, which did not help with the descent and resulted in the airplane initiating a climb to the 3,000-foot altitude that was previously set. To prevent the climb, the pilot disconnected the autopilot and retarded the thrust levers to idle. This resulted in the autothrottle transitioning to hold mode. In hold mode, the autothrottle does not control airspeed. Descent rate increased to about 1,500 feet per minute, and the observer pilot noted sink rate. About 1.4 miles from the runway, the airplane descended through the desired glide path and slowed through the target approach speed. The pitch attitude steadily increased as the pilot pulled back on the column in an effort to maintain the glide path. The airplane was well below glide path, and airspeed was 15 knots below the desired approach speed and rapidly dropping. 11 seconds before impact, an audible alert sounded because the airspeed was too low. 4 seconds later, the pilot monitoring advanced the thrust levers, followed by stick shaker activation and a verbal call to go around. These actions were too late, and the main gear and the underside of the aft fuselage struck the seawall.
So you saw there the actual event, and a couple of things. One, we wanted to demonstrate the ease with which you can pull video assets and feature them in this sort of live setting to enhance the experience. And I know, DP, you wanted to share just a few thoughts as well.
Yes, Paul. So if you look at the safety board, what exactly they found at the end, what caused the crash here, the several, the top of it had to do with training. The pilot was extremely intelligent, experienced, but needed more updating, and the system was not fast enough getting that kind of training going for the pilot. Now, the training was of two kinds. One is the technical training, because he was experienced in one type of plane, another plane he was flying the other day. And the second is that the leadership training, the soft skills training, and the idea that if he could have aborted towards the end, that option was there. But the over-reliance on automation, to think that the machine will do everything right, that was another factor. The realization and the training that needs to be given there is the human is the ultimate authority. And that came out in this report. So it points to training needing to get upgraded. You look at the C-level leaders today, there's widespread agreement, complexity is growing because data is growing. The learning and development is simply not keeping up. Part of the reason of showing this ability to meet in the lobby, come into a quick excursion to go immerse and get this interactive experience and walk right into the black boxes and so on and see that level of detail. And then the idea of debriefing, this is what Paul and Lisa have designed to show to us. This is a breakthrough in learning and development. And everybody can actually identify, I would say, the plane here symbolizes an enterprise organization, right, for under trouble. And the leaders of the cockpit represent the best of us. And the best of us need learning and development training. So upgrading that part is what this experience is about.
I was going to say, DP, I know a little bit about patient safety and airline safety, having worked with a Delta pilot who ran a patient safety company for a while in Innovation. And it's all human factors issues. And one of the sayings that they have in healthcare is that you have a bunch of experts, people who have expert training, but they're not an expert team. And so maybe one of the things that this kind of environment could enhance is how do we create expert teamwork? Because most accidents, especially aviation, are not because of people are haven't been trained in the instruments, but they are complex, and teamwork breaks down and communication breaks down, and that's when error happens.
So we do have a few more assets and a few more bits of information inside the fuselage if you wanted to sort of join me up there now just to check it out and see what's going on.
And Paul, as we're reflecting on this experience, imagine what it feels like in our industry, or the future state of where we want the industry to go, whether we're at the university level, enterprise, otherwise. It really gives us the opportunity to think, all right, VR, maybe my first impression was, this is too complex, right? This is going to be too much work for my team who's already crunched for time as it is. But what if this actually improves their productivity, gives them an avenue to innovate faster and in a renewed way, where they're getting more through the experience itself, and have those conversations that are typically hard to do. I think in the workplace, where you're in kind of your zone and you have your select set of responsibilities. So it gives people, I think, the opportunity to push the envelope of where you want.
Yeah, I totally agree with you, Lisa. And the real feel here, right? You can see, whereas a pilot in a flight simulator might be working in the controls, I think Rick made a great point. The notion of playing as a team together, and also putting into context and perspective the sort of risk reward, it's significant. And, you really get a sense in this environment of that.
So I come from the architectural engineering and construction industry, and as well as operations and maintenance of a facility. And, we went from, I've been 20 plus years in the industry, and we went from 2D CAD drawings, even working from blueprints to CAD. And that was a big deal, all the way to 3D modeling in the, late 90s, early 2000s, mid 2000s. And that was a big deal. But what we found is, and what we're finding in the industry right now, is through virtual reality, even in the design phase, we can have these amazing review sessions with our clients, designing buildings, and they don't get the full experience until they go into VR, and then it just feels different, right? They feel their space, kind of like, it's like the dome. The dome's very simple though, but and also within the industrial environment, you start to see safety hazards, right? We're walking through semiconductor factories, kind of my specialty these days, and we see safety hazards. How's a person going to get to that valve? How's a person going to, access that filter to change it? How are we going to get a scissor lift in there? And then potentially 3D collaboration in the manufacturing space too. I have a product when you can hold it and spin it in your hands and put review comments and have collaborative sessions. And then the ability in AR to overlay a model that's not even built yet in an existing factory or facility and overlay that in the field and see how that's going to look. Whether, I'm a mechanical engineer, so I keep referring to piping and ducts and things like that. So if it's air, fluid, chemicals, or gases, that's my domain. But yeah, to see how that stuff goes in, it's just within, you get on your PC screen, do your thing, model it up, and just throw on a VR headset real quick, look around, and you will make better decisions, individually and collaboratively. So
No,
that's how it's impacted my life.
Yeah, that's really interesting, Mike, and it makes me reflect a little bit about my own life, and it must be Rick Stone's story intelligence rubbing off on me. But what I found is even learning and development and training, people don't want the same old things that they've had across their professional life. They want the education intertwined with entertainment so that they're excited to go to professional development training, where they're finding the experience more than something that they've just had hundreds and hundreds of times in their professional life. So this, what I've seen professionally when early on in my career, I reverse engineered life, take the most difficult path I could imagine, increasing the potential to fail to about 80%, just for the opportunity to learn. And a lot of times, I think at the university level, a lot of times researchers, you get bogged down in your own research, and it's easy to have those, like your door closed and just say, all right, I'm going to read the 20 books today and get further. But an opportunity to really engage and diversify your perspective, learn 10 times faster, and just really help you innovate in a different way, where your job changes because your everyday is different based on the new skills that are relevant and just in time.
Right, and if you look at the business outcomes, this is like going into the feeling part of it that Mike just said. Right, 100 years ago, Charlie Chaplin said this right: we think too much and feel too little. As humans, we have to do both. And living with machines, the risk there is we become like machines, and as humans, we are different. And so in terms of business outcomes, what is the thing that this actually enables? Number one is safety, right? You just see all the high-risk environments can now be simulated methodically. This is why big companies like Walmart, Bank of America, and so on are investing heavily in this space, because the customer satisfaction can be improved by training the employees with every major situation, the opportunity that you get. And secondly, the quality. If you are able to get people, what Mike used to say, better visibility and means like better understanding, better decision making. If you did that right, then you're going to be able to get first time right in what you do. And once again, the quality will go up and the customer is going to get better experience. We talked about the operations part of it, how the training and cross training, that's my favorite. If you're trained with one particular area, this particular technology allows you to train across different types of tool sets and so on. Suddenly you become a more agile organization. All of this should lead up to competitive advantage.
And it's so interesting as you're talking about business outcomes, DP, the majority of our workforce is not engaged. I've looked at recent research that says 78% are not engaged at work. And it looks like as people perceive happiness, they look at it as a temporary state of mind. But my experience working in the happiest place on earth, I think Utopian and also Disney prior, is that your employees, your employers need more. How could we transform our entire organizational culture where the productivity is going to advance by at least 13% based on the research I've seen, where people are excited. We've had in different clients that we found, people are like pushing back retirement because they're enjoying this opportunity to innovate and learn in a new way.
Indeed, retirement is now giving way to reinventing and reinvigorating. So it becomes a constant and continuous process called innovation. So, absolutely. Any other questions from audience here?
How long did it take you to create this this virtual crash?
I would say we've been preparing for it, right? And the whole 90% of this work are done in about 7 to 10 days. Just think about that. And of course, the team did, this extraordinary team that comes together, right? And everybody's like passionate about about this part. There you go. Thank you, Karen. And so I would say every single, what they say about a great team, there's complementary skills and everybody pulls together. And we call that the pixie dust, right? Why we're able to do in 7 to 10 days extraordinary things this. 90% of it got done. And why? Because we are passionate about helping clients, helping like people who are having similar challenges. Hybrid workplace is here to stay. Jeannie
And
is
I think
not going back. Go ahead.
I think what's interesting, Paul, based on some of our discussions, is the field research, right? People have been, case studies have been upended with pandemic, and people want to have access to more when they can't necessarily travel. So I would love, Paul, hearing your perspective from a university mindset, how virtual reality could really help offset that gap.
Yeah, well, one of the things that we started while I was at Stanford was research focused in Thailand, where a number of faculty were coming together across a number of disciplines to address, let's say, reforestation of the non-forest and the non-province. And this was business school faculty. It was obviously environmental faculty across the university, and when the pandemic hit and there was no travel, one of the challenges was how do you bring Thailand to Stanford versus faculty members flying out to visit. And so, part of the thinking in sharing this is, what are the possibilities? How might you actually think about using this environment to gather in ways that would potentially project the look and feel of the country and the sort of culture and so on. I think this is a dimension that goes missing when you have a 2D Zoom experience. So I guess constantly thinking about ways to extend and expand the technology to try to pilot your way forward, to experiment with new opportunities. And indeed, as I mentioned, the notion that my colleague was struggling with, what would an accident crash look like and how could you bring the pieces together? This is a fairly, again, low resolution, but you can imagine spending a little bit more time on the actual detail, literally taking photographs and modeling pieces of the aircraft that have crashed and so on. So these are a couple of quick thoughts, Lisa. I think the opportunity is enormous, in short. Business, education, etc.
I think it's really interesting. It makes me reflect a little bit, Jean, about your work in the theater and public speaking skills itself. I was just, I took about 700 Stanford leaders under my wing across industry just to help them, navigate this new frontier of a lot of unknowns that are kind of coming to the forefront of our mind, and thinking about VR as a safe space where you are confident and comfortable to have that conversation and present. Like even here in this moment, just to turn off your mic and share, that's a huge moment. And Jean, from your perspective, learning directly from Walt, I would love to hear your thoughts and how this feels.
One of the things that I am exploring with Lisa is created in an environment. Realize when many of us speak or share in a classroom, it's a rather sterile environment. The surroundings are well, they're not enhanced, and so you have to try to create an environment. But they're not necessarily immersed. And one of the things that this is just so exciting for me is that in an effort we've been talking about creating, because I work in motion pictures, is a soundstage where the participants come in and we wander around, and there's props and there's costumes and there's this great environment, and you're able to tell the stories and take them on your journey. And each one of the areas within a soundstage can take you actually anywhere in the world. Well, actually into the universe, or it can take you way, way, way back in time, or project you way into the future, but it's happening now, and you are there participating as a viewer, as somebody that is experiencing this world, your world. And so the enhancements, a picture's worth 1,000 words. Well, I wonder how many words it would take to create like where we are now, this crash site. You look around and you go, holy moly, this is pretty astounding. And for you to be talking about aviation safety or the miscalculations and so forth. You're there, and how much more impactful it is. So, but thank you, Lisa, for allowing me to share my few moments with you guys.
No, Gene, it's a treasure. We're actually hearing a word in the 2D world that Nick from Penn State is preparing a presentation. So we're actually going to all hop back in Zoom, and Nick's going to present there, and we're going to have some time for question and answer. Because I just heard also Steve
Lisa,
Moskowitz has a question.
let me interrupt. All with the power of technology and a really, really smart professor at Penn State University. We've solved this problem. We are moving forward, gang. We're gonna transfer from the mountain scene into the Stanford campus. We're gonna continue the program inside the Stanford campus. So
innovation on the fly. Yeah.
Innovation on the fly.
Innovation on the fly. We're gonna warp to Stanford right now. That's amazing. Welcome, everyone. This is the Stanford Graduate School of Business at nighttime. I know it's morning time for some of us, but evening for others. And it's incredible. I know, Paul, you and I feel very nostalgic in this moment from our common roots. But there's a huge opportunity when you think of university settings to bring universities and industries together in a common moment to learn from each other, to be in the field. So we're actually going to head and walk over here across campus, and Nick is going to be presenting.
Hey guys, just want to introduce Nick Meisel, Assistant Professor of Engineering Design at Penn State University. And Nick, we're so glad to have you here with us today. We are going to continue with the program. So take it away, Nick.
Cool, thanks so much. Can everybody hear me okay through this?
Yes.
Yes.
All right.
I can hear you.
Perfect. Great. Good to hear. So thank you for everybody giving me the time to talk today. I can honestly say this is my first time getting to present in a VR environment. So this is a relatively new perspective for me. So what I'm aiming to talk with you about today is sort of some of the research that my group and my colleagues at Penn State have been up to, looking at the use of virtual reality specifically for engineering education. So we're hoping to be able to illustrate to you how all of the stuff that you've been seeing today, right, through this platform, can actually be leveraged for education. We've got some results, some evidence that we can sort of present to try to show the very real effect that virtual reality can have on education results. So a little bit about myself. So as was mentioned, I'm an assistant professor of engineering design at Penn State in CEDTAP, which is our School of Engineering Design, Technology, and Professional Programs. So I came into engineering because I am passionate about design. That's what got me really excited about being an engineer. And so all of my work sort of tends to that design side of things, with a special focus on additive manufacturing or 3D printing. So that's what we'll be talking about today, is this idea of using virtual reality to completely disrupt everything we know about education for additive manufacturing. So as you can see on this slide here, additive manufacturing or 3D printing has transformative design potential. But the challenge here is that we have to be able to execute on this. So as you see here in this image on the left is sort of a traditional wheelchair, right? So it's a design that most everybody is going to be familiar with, made with traditional manufacturing. But if we want to rethink this for additive manufacturing, we have a lot of innovative design potential, leveraging things like lattice structures, we call free complexity in additive manufacturing as well, to completely rethink this to create a fully 3D printed wheelchair like you see on the right there. So again, it's a total change in what we typically think is possible from a design perspective. So one of our, this is why we're interested in turning to virtual reality, because virtual reality, we see it as one possible method to enable engineering designers to better visualize and understand complex additive manufacturing processes and the complex designs that result from those processes. So what you see here is a screenshot that I've pulled from our 3D printing simulation that we've created in virtual reality. And I'll show you the picture here in a minute. But on this one, we actually have our Nittany lion. So this is our university mascot that we have pulled off of the build platform of our virtual 3D printer that you can kind of see part of in the background there. So in VR, a student can go into this environment. They can take this file, they can place in that little box that you see there in the bottom left corner, and then they can watch the part print off on the build platform on the right. And we actually have some sliders in there that allow you to speed up the print or slow down the print so that you can see more details. And then when it's done printing, the student can go and they can pick it off the build platform and actually look at it in virtual reality in a much more organic nature than they would with a traditional computer. So what's really advantageous about this is that we can represent a whole host of different additive manufacturing processes in virtual reality. So on the left, you see a relatively typical desktop 3D printer. So these aren't too tough for students to come by. They're relatively office and classroom friendly. And you can get some of them now for as low as $200. So they're relatively affordable. So we can create those in VR, but that's not where VR necessarily really shines. Instead, where VR is really advantageous to us is in like the system that you see on right there. So this is a metal powder bed fusion system. Now these printers are much more difficult for students to engage with. The reason why is because they require a ton of user expertise to actually be able to demo them. And there are, frankly, a lot of safety hazards associated with running them. There are a lot of PPE requirements to them. There are lasers involved that need certain degrees of safety. And so getting students access to learn on one of those machines is actually quite challenging. So this is where virtual reality becomes super beneficial for us in this area, is being able to give students a chance to get quote unquote hands-on with a technology that they may otherwise never be able to experience during their time as a university student. So what's really cool is we've been able to go through and do some real in-class experimentation with students on these different systems. So this is kind of showing some of the learning gains that we see from students when they're using, in this case, the simple desktop material extrusion system. What we see is that if we give students, say, a content quiz before they participate in the intervention about how does 3D printing work, students tend to start at about the same level, right? If we have a big pile of students, everybody's more or less at the and then if we teach half of them in virtual reality and half of them with a real physical printer, what we see is that we get similar knowledge gains in both mediums. So this is really promising for us because it shows that we can, in theory, get sort of really meaningful knowledge gains out of students, even in a completely virtual environment that might mimic the gains from a physical environment. So that's on sort of the process side. And that's just about understanding how does this printer work. But to really elevate our designs, designers also have to get really comfortable with the idea of how do we evaluate incredibly complex designs. So these are a couple of different designs that are out there for various products using metal additive manufacturing. You can see a lot of these products look nothing like day-to-day parts that we might typically be used to working with. So we have very organic structures, very complex geometries, very fine features. So we have this question of, can we actually use virtual reality to make it easier for students to understand the quality of these parts, right? So that they can actually immerse themselves in the designs. So to try to test this, what we did is we had students use a traditional screen-based interface. So just a 2D screen using computer-aided design, sort of the typical software that they're used to, interacting with a part using just a keyboard and mouse. Then we gave the other half the same sorts of designs to look at in a virtual environment. So that's that fully immersive VR environment. And we gave them parts of increasing complexity. So we started from very simple parts that were sort of basic geometries, no real complex elements to them. And then we slowly added different levels of complexity. The idea being we wanted to see if we give more complex designs to students, do we see more benefit from having that virtual environment, right? So do we see that CAD environment becoming, and so you can see the designs that we used here. We included this little penny alongside them to sort of give the students a sense of scale. So the results on this were incredibly promising. You can see two pictures of the students participating there up above. So you have your traditional screen-based environment, then you have your immersive environment. And what we found is that as these designs get more and more and more complex, we're finding that students make significantly faster evaluations of part quality when they're using virtual reality. So if you put a student in that immersive environment and you hand them a very complex part, they're making much faster decisions about the quality of that design, which is incredibly promising because it sort of aligns with what we were hoping. We wanted to make sure that that VR could provide sort of that intuitive environment to evaluate a part within. Now the only downside of this is that we're finding that they're getting slightly less accurate evaluations in that VR when compared with a more traditional 2D screen. So our next goal is to try to balance this, to try to make sure we can maintain those gains in evaluation speed, also bringing up some of the accuracy thanks to that VR environment. And ultimately, the grand vision that we have here to try to transform our design and manufacturing cycle for additive manufacturing is to be able to do all of it in virtual reality, right? So if a student can have some sort of sketch, right? They can go into a virtual environment and they can model the design, right? So they actually get that feedback as they're modeling within a virtual environment. Then they can take that item that they've designed in a virtual environment, send it to a virtual printer like I showed earlier, and actually watch it print out either in real time or sped up if they want to, and then pull it off the build platform to look at it and evaluate it and understand the ultimate quality of it before they ever have to go and create the actual physical artifact. So allow us to reduce that iteration time and hopefully end up with much better quality products in. So that's sort of a very broad overview of the type of work that my group is up to. As part of this, I have to acknowledge my colleagues, Dr. Tim Simpson, Dr. Scarlett Miller are also working on this project. And then all of the students in the lab who actually make all of this awesome stuff possible. So happy to sort of answer any questions you might have at this point.
So thank you so much, Nick. We really appreciate you crossing the chasm and hopping into VR. What I think, in the interest of time, let's all hop back into Zoom and answer questions there. So that sounds great. And I want to thank you so much for this. I've learned a lot.